Hello, welcome, or welcome back, whichever the case may be, Microsoft Virtual Academy. This time, Security Fundamentals, Module 4, Understanding Network Security. I'm here with Christopher Chapman. I am Thomas Willingham, and we are here to help our audience.
I'm just here to silently stare in awe and wonder.
Make things awkward?
Yes. That is my role.
So we're here to understand network security further, more.
Well, we're here to help
better.
them understand it.
Well, yes.
I mean, I'm hoping maybe we can understand it more afterwards, but I'm hoping there's not too much of, oh, that's how that works. By the way, not a good thing to do in a class full of people when you're teaching something. Oh, that's awesome. I didn't even know
I didn't know it did that.
That's crazy.
Might lose a little bit of credibility.
Just a smidge.
A little.
Depending on the importance of the feature.
Exactly. Module overview. We're going to talk about firewalls, network access protection, network isolation, protocol security, and wireless network security. So first of all, firewalls. Firewalls protect a computer, a network, or a network segment from network-based attacks. It performs filtering of data packets traversing the network and can basically filter out different kinds of content. Different types of firewalls will filter out different kinds of content. The graphic here gives you an idea of how it might work. So you have the internet traffic hits that firewall. That brick wall in diagrams is a pretty typical icon used for a firewall. Notice after that the traffic has gone way down. So just a lot of stuff that the firewall might filter out. It might filter out web traffic. It might filter out telnet traffic, email traffic. It can filter out a variety of traffic to hit your corporate network. So the OSI model. If you took or watched the Networking Fundamentals course, you should be familiar with the OSI model. The OSI model, Open Systems Interconnect model, is a model that enables networked devices to intercommunicate. There are 7 layers within the OSI model: application, presentation, session, transport, network, data link, and physical.
Now, the next couple of slides here go through all of these layers. We're not going to spend a lot of time going through them individually. It's not that pertinent to the security course, the security exam. Not to say it's not pertinent to security knowledge. At some point in your career or as you advance through security, you may get to the point that the individual layers of the OSI model make a big difference. They typically don't. I mean, we're not worried about security from an individual OSI model layer standpoint. At least I've never been. So the next couple of slides have this information. We're going to breeze through them pretty quick, but this deck is attached to this video in MVA, so you can grab it, take a look at it, read more about it if you want to. So just a little preface, a little warning there that we're going to go right through this really fast.
Right, so we're basically just going to take each layer of the OSI model, very quickly review it, and continue on. So layer 7 of the OSI model is the application layer. It receives data from the user and passes it to lower layers in the OSI model. As responses come back up, it presents that information to the user. The presentation layer, layer 6, converts application layer data into a format that permits the data to be transmitted across the network. At this level, there may be a bit of encryption of the data for transmission and decryption of responses. Again, if you want to know more information about the OSI model, please look up the OSI model in the Networking Fundamentals course. The session layer. This is responsible for data synchronization between applications on the devices. The session layer establishes, manages, and breaks sessions between devices. The transport layer provides a mechanism for transferring or carrying data across the network. Uses 3 main mechanisms: segmentation, so the breaking apart of messages; service addressing, so ensuring that the address on one side is speaking to the appropriate address on the other side; and then error checking, ensuring that the packet traverses the network without errors being introduced. Layer 3, network layer, is responsible for routing, so transferring across networking segments. Layer 2, the data link layer, connects the data link to the physical layer so the data can be transmitted across the physical network. It can handle error detection, error correction, and hardware addressing. And the data link layer is actually broken up into two sublayers, the media access control or MAC sublayer and the logical link control LLC sublayer. And then the physical layer is the actual, layer 1, is the actual physical topology of the network. Ethernet, token ring, fiber. So basically, said it again.
Not that much though. It's
I'm trying to, like I said, trying to wean it out. So it defines the physical characteristics of the network media. The OSI model data flow. So this shows you how a packet at the top of the model here. So basically, it's not what I wanted. I want that. Here we go. So something at the top of the model here. So as it enters the top of the model, we have the packet and the data. And as it translates or transfers down the model, each layer adds its own component to the model. Then it gets transferred across the network. And then as it goes back up the model, that information is stripped off until we're back to just the data. Packet filtering firewall. This is the first generation firewall. It specs packets at layer 3, the networking layer, based on rules that define what types of packets are allowed or denied to cross the firewall. Very simple, straightforward packet filtering. Circuit level firewall. Second generation firewall, similar to packet filtering, but operates at layers 4 and 5. It analyzes data at the session layer. So once a session is established between two devices, all packets for that same session are allowed. So once a client and a server have established communication, then it allows all of that communication to go through. This is fine except for, say, maybe a man in the middle of attack. And what this refers to is you have two end devices. You have a device that injects in between and starts intercepting. If it's intercepting data and putting on different packets in between to intercommunicate, this level of filtering or firewall may or may not catch this type of problem. Application level firewall, so third generation firewall, analyzes data and application behavior at layer 7, also referred to as proxy servers. So again, just a little bit higher level, takes a little bit more processing power, and is a little bit more involved. So in the next...
And to keep it simple, our last bullet.
The last bullet. Most modern firewall products work as a mix of all three generations. So you hear about devices, a switch, a router, a bridge, a firewall. And it used to be that all these devices were very specific. This is a bridge device. This is a router device. This is a switch device. This is a firewall. Now, it's not uncommon that one single device will have multiple functionality. It will act as a firewall. It will act as a switch. It will act as a router. So as you look at devices, ensure that as you're looking at devices that you're comparing apples to apples. You may see one device that's priced X. I'm not picking any specific device, but let's say we have one device that's $100, and we look at another device and it's $1,000, and they both say that they're routers. Well, maybe the $100 router is just a router, and the $1,000 router is not only a router, it's a switch, it's a firewall. So really look at the products and dig into what they have in them, so to ensure that you're comparing apples to apples. So host firewall and network firewall, so as devices are intercommunicating here. The host firewall, this software protecting your computer from network-based attacks, also known as a personal firewall. So a host or your individual client computer. Versus a network firewall. The network firewall is a firewall for a network segment that basically moderates network traffic. So host, let's step back for a second and think about the fact that all network traffic travels all over the network. Once a device puts something on the network, it goes to all devices on the network. A host or client firewall filters out stuff that's not meant for that client or that's not pertinent for that client. So if my client isn't a web server, it doesn't host RDP sessions, it doesn't host email, you can shut those ports down and have those firewalls block that to ensure that, back to nefarious or malicious, that those packets aren't coming in that your system might try and process that could cause problems. Versus a network firewall protects a network segment. And now we have, it's demo time. Demo time of the networking or the Windows firewall.
Alrighty, well, let me get that spun up here real quick. And what we have here is a fun adventure because, well, I'll show you, because why not? Get logged in, close our group policy, and we're just going to start from a clean desktop. And here we have our folders from earlier. We've got the same demos. I'm running on the same machine. And we're going to jump right into the firewall. A lot of users on desktop computers, laptops, maybe a Surface, might be familiar with one of these options. I'm going to hit start. Now again, this is 2012. This may look a little different than 2008 or 2003 if you're using those. But we're going to the same destination. We're going to go to the control panel. This should look familiar. Firewall, still not in here. I'm going to change this to small icons because it's just my preference. Now there is Windows Firewall. This, relatively straightforward, connected. It shows you your different profiles and your connections. I can allow an app or feature through the Windows Firewall. Now, I can sort of speak to this. I'm not a big wizard fan. I don't like wizards doing the work for me. I'm gonna get in and figure it out and change it at its root kind of a fan. I'm not gonna go that far because it's all buried inside of, I want to say group policy. It's actually buried in the registry that these things are kept on local machines. We're not going to that level. But here, I have options that already exist, Windows services, Windows roles, different Windows communications mechanisms, and I can allow these via the checkboxes through different profiles, domain, private or public, depending on what I'm connected to. Now, I can allow another app. This is the part where I'm not a huge fan because it kind of limits my ability to configure. Yes, this will work. I can allow applications as long as they show up in this list, which not all applications do, or I can browse to them, which most applications I can get to this way, it's going to work, and I can allow them through the firewall. I'm a little bit more, I want to say fundamental. I don't know if that's the right word, but we're going to go with that. And we've seen the Windows Firewall. This is your list, and the allow another app is how you allow an application. And then network types, you can select which ones are yes and no. I like to be a little bit more granular, so we're going to close this. We're going to go back to Control Panel, but we're going to go one level deeper into Administrative Tools. And all the way down here, hiding at the bottom, Windows Firewall with Advanced Security. This exists on all Windows computers past, I want to say, Vista. I don't remember if Vista had that or if it's just Windows 7 and later, but this exists, servers and clients. This is my kind of configuration tool. Inbound rules. Yeah, this is where I get to really strut my geek right here in this course. I like this. This is my kind of an interface. And most of it is because I have more options. This is just what is and isn't existing. These are created. Green is enabled. Gray is disabled. They exist, but they're turned off. And then all these options, which profiles are attached to, whether it's enabled, what action, because I can specify specifically allow or block. override which program it is if there's a program associated. Local and remote addresses if we're keeping it specific. Ports if I want to go with that. All of this is in this table, but we're going to create one so you can actually see how you build it. This right here, I already like this more than the other firewall because it's giving me these options. Yes, I can allow a program like I did in just the Windows Firewall Control Panel app. But I can also go per port if I don't want to tie it to a particular program. I may have, for an example, I may have an email server that I have a number of applications listening on a given port, or it depends. It depends on the setup of your network. And I don't want just a program. I want to allow everything on that port. So I can do that. Or I can do predefined. And these are services and roles that Windows provides as a Windows server. Or I can go custom. I'm not going to worry about custom because it's a lot of information, although port should have some of those. TCP or UDP, all or specific. Now, you can't do both at the same time. So if you were to want to allow a port that needs TCP and UDP, there are programs out there that need access to a port on both of those protocols. You'd have to create 2 rules. But again, it's granularity. I'm okay with granularity. And then you give it a port. Let's say 80. I don't mind opening a web port on this isolated non-network connected VM. Allow if it is secure, and this is IPsec based. We're not going to get into this. This is a security topic and a terrific security topic, but it's a more advanced security topic. So this is going to be covered in the MCSA course series, the 410, 411, 412. Or I can block it. I can flat out say, do not allow this. Now, typically, what's the word I'm looking for? A lack of a rule is a block. If I'm not explicitly allowing it, it's not allowed. But there may be, let's say there's a program that I'm allowing. That program may communicate on multiple ports, but I don't want it to communicate on, in this case, port 80. So I'm blocking port 80. Now that may interrupt the communication or the functionality of that program. But again, I don't use program rules very often in the firewall. I'm going per port to make sure I know what's going on. Allow is the easy option. Profile, do we want it to apply to all? No, if this is connected to a public network, if I'm in an airport, we'll visualize instead of a domain controller, this is my laptop or even my desktop at home. If for some reason it detects it's not connected to my home network, maybe I've taken it somewhere else. I hate to go here, but anybody watching this may have participated in a LAN party from time to time.
Yeah.
And if I take my desktop, which I do run a domain at home, because again, we're strutting the geek right now. If I take that desktop away from my house and I'm no longer connected to my domain, I'm going to plug it in somewhere else, it's going to come up as public. I don't necessarily want all my friends browsing content on my computer. So I can uncheck this box as I'm blocking these ports and then give it a name. I don't have anything more creative right now because it's just an example. Done. Now in this list, port 80. And done. And that's the more complicated Windows firewall. And that's pretty much it. That's the 2 of them. You can modify anything that exists. Core networking. You want to change this, you can. Now this one, because it's, you'll notice this is all grayed out. It's because of the fact this is based on the system. These are all pre-built rules, again, that may have different configuration options that limit what you can do in here. There are other reasons for this. I can, to some degree, control firewalls with group policy. I may have rules in here that I either can't control or can control, but will suddenly revert after a certain period of time. So all those things apply. Trying to keep it as light as I can. I think that's good on the firewall. So 1 in control panel, right here, and one level deeper in administrative tools, right here.
And again, those were firewalls for a client, not a network segment. Although the network segment will have similar functionality.
Well, it depends.
The concepts can be the same. Blocking, enabling applications, protocols, ports,
Yep.
or disabling.
Yep. And technically, since you can use a Windows server as a router using routing remote access services, I could end up in an interface very similar to that to actually control the flow of network traffic across segments. Not a likely scenario, but it's possible.